All right. What's up, YouTube? Here we are for another exciting night of Advent of Code. Yesterday went pretty well, so we'll see how today goes. If we take a look at the stats, it's kind of interesting to me. It kind of shows you where everybody's at. It looks like people are keeping pace. Pretty good numbers still being completed here, 41,817. Um, oops. Only a few who didn't get through part two on this particular one. I think part two honestly was easier than part one in some ways. It was almost inversed. Like I actually found the result for part two before part one. So then you've also got personal times. Um, day I did the next day, so that doesn't really count. But some of these are pretty bad. Some of these are not so bad. Yesterday's was not so bad at all. So we've got about 3 minutes left, so we'll dive in as soon as it starts up. For those that are joining us, feel free to ask questions or comment. I'm really not doing this for ultimate speed, but rather just working through the problem. So my goal here is just to, if I can, complete all 25 challenges this year. I know from past experience that as we get closer to like in the 20s, 21, 22, 23, in that area, you start to run into things that require some advanced knowledge of math. Oh, really? Yeah, day 9 was interesting. The disk fragmenter. I'm actually thinking about visualizing this one next. I think that'll be fun. I ran into a bug when what tripped me up for a while with this one was that the slices in Go are references, and so I was I was modifying the underlying position slice and not realizing it, which gave me answers that were off for a little bit. But it wasn't too bad. What I ended up doing was I was grouping each of these positions as like blocks on the disk, and then these as free space. And so what I think the other part that tripped me up was as you move them, I was modifying the size of the slice and my indexes were getting out of position. So once I figured that out, it was pretty smooth. But I ran into a few issues on day 9. Uh, Pedantic? Are you writing in Golang, or what language are you using for Advent of Code, or writing in Advent of Code? I really guess you could switch from day to day. Just out of curiosity, uh, what are you using to tackle these problems? Right. Okay. Just double check our setup here. Nice. Nice. Yeah. It goes my day-to-day driver. I've looked at Rust a couple times. Um, man, I just, the syntax is a little heavy for me. Uh, I spent a lot of time looking at Perl, and it kind of gives me some flashbacks of Perl in some ways. I know that's not a true statement for Rust, and Rust is completely different, but just there's some things that I see and I'm like, okay, this just reminds me. So I've been kind of staying away from it, but maybe I'll dive in and start messing around with Rust from time to time. I haven't really built anything, not even a sample app in Rust, so maybe I should give it a go and see. All right, 16 seconds. Do you like Rust over Go at this point, or are you just trying out Rust to give you some more? That's fine. Day 11, Plutonian Pebbles. The ancient civilization on Pluto was known for its ability to manipulate space-time, and while the historians explore their infinite corridors, you've noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Sometimes the number engraved on a stone changes, other times a stone might split in two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first application rule in the list. If the stone is engraved with the number 0, it's replaced by a stone engraved with the number 1. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the right stone. The new numbers don't keep extra leading zeros. 1000 would become 10 and 0. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024. Does that mean if it's a single digit number that's even? An even number of digits. Okay. Gotcha. Not even, but an even number of digits. The left half of the digits are engraved on the new left stone, and the right half on the are engraved on the right stone. Okay. No matter how the stones change, their order is preserved, and they stay on their perfectly straight line. How will the stones evolve if you keep blinking at them? You take a note of the number engraved on each stone in the line, your puzzle input. If you have an arrangement of 5 stones engraved with the number 0, 1, 10, 99, 999, and you blink once, the stones transform as follows. The stone 0 becomes stone marked 1. The second stone 1 is multiplied by 2024. The third stone 10 is split into 1 followed by 0. The fourth stone 99 is split into 2 stones marked 9. The fifth stone 999 is replaced by a stone marked, because that's, if I'm not mistaken, 999. That's not it. 999 times 2024. Why? The fifth stone is replaced by a stone marked 2021976. Well, that's not it. Why is this true? So after blinking once, I'll come back to that. Your first stone would become an arrangement of 7 stones engraved with a number 120241099202197. Here's a long example. Initial arrangement. After I blink, after 2 blinks, after 3 blinks, after 4 blinks, after 5 blinks, after 6 blinks. In this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, you would have this. Consider the arrangement of stones in front of you. How many stones will you have after blinking 25 times? Okay. So we'll start with this then as our initial input and put that in our test file. And we know after 25 times, it's 55312. And so that will be that. I still don't understand this. Why is the fifth stone? Let's go back to the rules. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 separate stones. Left half of which are engraved with the new stone left, right, right. The new numbers don't keep extra leading zeros. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. An even number of digits. But 999 is not an even number of digits. Why is this not working for me? The old stone's number multiplied by 2024. Um, Wait a second. Is it 5 times? No. Well, that's right. Oh, that is the right number. What am I? Why am I being so dense right now? Okay, so we could do this. So we need to loop through 25 times. All right. So we're gonna load in this. Our input is separated by space, so we'll give it a space. We're gonna treat this as strings, just because that'll be easier. And then we'll do for. Actually, I don't think I need this number. We're going to keep looping through. We can get rid of that for 25 times. And then we're going to apply these rules. So we'll copy this real quick. And we'll say for actually we'll do I range of M sub 0 because there's only going to be one list. That's fine. We could just probably actually do a strings.split. Let's just do that. We'll do bytes dot strings. We'll work with strings. So that's our inputs. We're going to range over that. And then we're going to say if yeah, actually we're going to want to do if. So we're going to be constantly modifying this slice. And we're going to have to go to the end of it. So actually what I'm going to do is not do this, and I'm going to say for and just loop through. And what we're going to say is I will assign it out here. So I is assigned 0, and then we'll say I is if I is greater than or equal to greater than the length or equal to the length of M, we're going to break. All right, so that way as we add 2, because we're going to be adding things to this, and that's going to get us to break out of here. And then we've got that, and then let me just do that. Right. we'll go with that. And then we'll say if m sub I equal what I don't know is if I put this up in actually this for loop, does it reevaluate the length of I each time? Or m rather? We'll see. I could probably just eliminate this if that is the case. And then we go with and then if the length of I, so we want the length of m of I mod 2 equals 0, then we are going to split this stone, however. And so the way we're going to do that is we're going to take the value divided by 2 of m yeah. And this is going to be essentially the same thing for the right side. I did that just because we're going to take m sub I and we're going to assign that to what's considered the left here. Because it's m sub I and then m sub I. Right. And then what we're going to do is slices dot insert. We're going to say m, or we're going to say comma, and we're going to insert at position I plus 1. And we are going to, okay, is there strings? Is this a thing? So let's see here. We could just make this a byte array. I'm pretty sure that'll just make this easier. Bytes dot split. We'll shift this to a string, and we'll call this Yeah, I think we can do that. And then yeah, okay. Well, that's no fun. It's ugly, but all right. We're going back to strings. It's fine. It's fine. It'll be fine. And then we'll just have to restitch this back together, which is not great. It's not, but it'll be okay. So what we want then is m sub 0 to I plus right plus m sub 0 or sub I plus 1 . I guess I could use a string buffer. Take that away. And that's our expansion. Otherwise, we are going to take the value that is there, and we're going to do is strings a to I and we're going to take in our m sub I and we will do B. And that should be it. So if we run, we've got 2 and not whatever. Oh, and then we've got a score, our score here. So our final score is going to be how many stones. This example, 22 cents or blink 20, you'd have 5, 5, 3, 1, 2. Yeah. Okay. So then it's length of M. Let's see here. 125 becomes 253,000. Okay, so that's wrong. So, oh, I have this inversed. We'll just do that. See here. Becomes 25, which is wrong. This should not be. All right, that's pretty slow. Let's just do this one time. See what we get. All right, one time, 125. Where is this first print? It becomes 1 and 25. That's wrong. So 125. Oh, I did have it right initially. Okay. So that becomes that, and 1 and 7 becomes 1 and 7. Okay. Cool. And if we go back to, let's do it 5 times. Okay. Let's look at our amount of code here. Let's compare. 25, 300, 1, 7, over 3, 1. So why didn't this not get multiplied by? No one knows who I am. It's all good. Ah. So that works. So what I'm missing here is the I position incrementing. So I don't want the I position to increment each time necessarily. If I split, which is where I think I'm getting lost here, this is kind of working. We do the 25,300, and then I'm continuing here. I don't want to continue here. I want to, well, I do want to continue, but I don't want to increase the index. Well, I do want to increase the index. If I split, I actually want to go, well, this is not a split. So if I'm here, I want to go to the next index. That's fine, which is what brought us here. Instead, I actually want to log here because this will give me a better idea of each iteration, what we're actually looking at instead of each step of the iteration. Yeah. So 125, 17, 25, 300, 1, 14, 68. So this one here, I think this is where we're getting hung up. $14.68, because when we split, we went ahead and went to the next iteration, the third iteration, which was 14.68. We did the last number already, but that's wrong. So when we do a split, we need to do an I plus plus. Yeah, okay, so 2517, and then 253, 0, 2024, 14168. So this split, which was good, but this is a 0 for some reason. We'll just we'll do this. Okay, so we didn't get an error. I don't know why this is a 0. I'm kind of caught up on that right now because it should be a 2024 253. This should be reduced down to a single 0, and we'll get that in a second. This should be a 14168. 14, that's correct. But this number here is not multiplying. The V, the A to I of the M of the I index is not multiplying. So why? So we move forward an iteration and then 0. Hmm. So 253. Is it because this is splitting here? Or is it attempting to split? Right. So multi 000. Okay, so it's split. Hmm. So that's right. Just to make sure that's saved. The the only thing I could think of is that the I actually isn't iterating in this for loop if I plus to it. Set 0 to 1, multi 0, multi 253. It shouldn't be multi 0 here because of this. Just gonna do a little bit more. Is my context of I getting overwritten here somewhere? No. Yeah, it should be skipping this. I don't think that is it either. See, multi 0, multi 0. That's right. Okay. Splitting 25, 300, multi 7. Like skipping the 1 here for some reason. Um, let me just change. Let's just do this myself. We'll assign I each time. And then we'll say if I we'll break out of here. And then I'll do something like so each iteration, we're going to go to 0 initially. If I is greater than or equal to, go back to doing this because I think this is fine. Index of 3. And that is going to be probably on this concatenation that I'm doing here. 144. Oh no, it's there. Okay, that's great. If I greater than or equal to the length of m, we're going to break out. Yeah, we'll put that here instead, where it should be. See what I have here for this state, because this might be the issue here. Yeah, okay, so that's our problem. So we're overriding it with a 0. So if I take this back and put it back the way it was, because there wasn't a problem here, I was just overthinking it. And so now the right is the length that we take everything leading up to, then we append the right, and then we append everything else to the left of it. And so we're missing taking the left side plus the 1 index plus the right side. So that's what we want, 253,000. of I plus 1 so what is setting? This is only after the, like, what, second iteration? Something like that. Yeah. So it's after the splits. This is where my bug is, and I just can't see it at the moment. So we're setting left to the 0th position to the length of the m of sub I divided by 2. Saying right to the opposite of that. And so our left and right is 2, 5, 3, and 0, 0, 0. And then right is only getting set where it's appending to m, or well, taking m from 0, 1 plus 1 to 1 plus 1. Then it's appending right. And then we're getting m of that. Is that the issue? So why do we get 171 here? That's not right. So that's right. Is it because it's not always m of 0? It's m of I. On. It's everything that's in that list up to the position we're in, plus the right side, the thing that we're inserting. Is there not just the strings dot? Let's gonna do a builder. I'm like, the split after m. So I get everything on the left side plus my right string, and I take that and I append and I've already modified m of I, which means it's going to have my left in it already, which is the 0 to the length of m sub I divided by 2. And then the right is the right side of that. And we know left and right is correct because we have it here, left and right. 253, 1, 7, nothing. Okay. Two, 5, 3, 1, 7, nothing. 7 is sorry. 2, 5, 3, 0, 1, 7. That's what I want, but I get this. Maybe because I'm manipulating this, that's the problem. And if I do that, that's the issue. Maybe because I'm doing that multi-tiered append, that we're getting some curb stomping here. So after split 253, and then we got 253, 0, 0. What in the world? Let's do a slices dot clone here. References. References will give me every time. And then we're going to do this. We're going to say all right. Let's try that out. So if s of sub I not equal to, then we return that. Didn't work out so well now, did it? Let's see here, 1, 2, 5, splitting 1 and 7. Don't get either of those, so I know that this remove leading is wrong. And why is this not working? Is it because I'm removing one too many characters? It is. All right. Okay. Return that. Return that. Yeah. Okay. 253. Should be 253 0 2024 1468, and it's not. So after just 2 iterations, we should be here, and we are at, this did not get multiplied, nor that got multiplied. So why did we not multiply? Multi 1, multi 7. Oh, is it just because I need to do technically a third iteration here? Is that the problem? I just didn't have it because two five three zero 2024 14 16 8, and then 5120 1 20 24. Why did that one? Is it just, oh, because I think it's because I'm logging here and I don't have a final log message here. Yeah, okay. So then we can, I'll just leave that one maybe in, and we'll take this one out, and we'll take this out and this out. And this should solve it for the first problem, which took me an hour, which is not great. Yeah, so then we should just have to do the length of M for the score. I need to set this to 25. It's a really long time for a test. This means I've done it really wrong. Okay. Well, this is poorly slow. I think my hint should have been, oh, well, at least we passed the test. My hint should have been here at 55,312 stones. That's pretty indicative of what we can do. Now, thinking about it, if I know at every stone that each stone is either going to manipulate itself or it's going to insert and move, they never combine. What's my puzzle input? Well, this is my puzzle input. Is there a chance that I could just get past part 1 here? I'll let it run while I think about doing this a more optimal way. Um, um, okay. Are you giving me 0? Stay 11. The test worked. Hold on. Ah, okay. Fortunate. I still have a log message in here. Okay. Probably did not need to see all of that. Try again. All right, so more optimal way. Maybe I should have thought through this a little bit further, but what we could do is we could, I think, loop through each stone all the way through and expand it as far as possible 25 times. And I don't know if that's going to save us any operations, though. It'll save us from overall looping. But maybe we can do something better with building these slices out. Do we need to build the slices out? Do we just need to know what the count of stones are each iteration? So we don't actually have to build the slice. Okay. So Okay, maybe we don't call it the stupid way. Maybe we call it the brute force. I didn't really think this through way. Um, we'll call this one part one better. Part one less stupid. How about that? Yeah, we'll call part one less stupid. Yeah, so I think actually what we can do then is instead of actually constructing the slices, we'll count them. Appreciate it. Thank you. Thank you. It's fine. So I'm taking pedantic. You're already finished with part one and part two. Yeah, let's do this. We're going to create a func. I'm just going to call it step. And I'm going to take in my slice. Or actually, I don't need the slice. I just need the string. And I need the num of int. And I will provide it a step. And then I'm going to do this. So we're not actually counting the values. Yeah. Yeah, I figured so. Okay. Well, good for you. So then we can return I want to return an int. And if I can think about it this way, if this is true, so if the input string is 0, then we can do we need to bring the total all the way down? I don't think so. Right. So then we can step 1 and our num is num plus 1, something like that. Return step 1, string of 1. Cool. All right, so then if this is true, then we actually don't have to like split and reconstruct anything here, but we do need to like remove the leadings. I'm gonna keep that, and then this just goes away because that doesn't matter anymore. And I want to call this S, this S, this S, and this S. Right, and then we want to return step, and we'll call this, we'll do left num plus 1. Maybe we'll do a variable for that. Step right num plus 1. Yeah. And then else, we'll leave that in there, leave that in there, and we will return step, etc. And maybe we will do if num I'll call this next. I'll call this step. Yeah. if step greater than 25. Return. Call total. Call this step total. Next. Yeah, I think we could do it this way. And these are not references, so those should be fine. And then, of course, this. Yeah, I didn't do one with the trick. I didn't know. Well, it depends on what year it was. Because I only think started in like 2023 or something like that. Yeah, so then this just needs to be a... Or maybe I started in 2022. Yeah, something like this. This should be... That should be better. And then what we end up doing then is we get rid of this ranging here completely. This is the less stupid way, right? Yeah, part one less stupid. We'll get rid of all of this, and instead it will just be for we'll say score, and then score plus equal I don't like the name next now. Oh well. And we do something like that. And then we get rid of that. And we do that, I think, is what we want to do. And then the slice itself doesn't really matter at that point. I think... When do I ever set total? That's the interesting thing. Yeah. Yeah. So... One plus next. I think I can actually take total out here. Because, like... Let me just leave it in there for a second. I think we can get rid of it. So this is interesting because there are two possible paths all the way down. Actually, do we just call this 1 and then that'll be done? We just, once we get down to the 25th step or over 25 steps, we just always return 1. And then 1 will just tally up and add all the way up into the final total. Is that what I'm thinking here? Yeah, that's taking way too long. All right, so we'll replace our part 1 with a part 1 less stupid. And maybe we'll go into our test here first. Oh, I just went ahead and ran it. Yeah, expected 55. It's not quite double, is it? Yeah. Oh, interesting. Yeah, I don't think I didn't do any 2021. Right. So I think I'm on the right track here. This is a lot faster, but my totals aren't right. So why are they not right? Start at 24, index 24. That would be a part of it. All right. So if we're greater than 24, we've gone our length. We probably should pass that in, but I'm okay with that for now. We're returning 1 plus next. We decided we weren't going to do that, and we were just going to return 1 at the very end because that's the last stone that we have. And there we go. Okay. So let me just get rid of part 2 for right now, since we have the less stupid way. I'm going to leave it that too. I'll leave it as that. That was much faster. So no brute force for the win here. And we got that. Awesome. Part 2. Sure, taking a long time to be fair. The infinite corridors are very large. How many stones blinking total? 75 times. All right. We are just going to... we're gonna... So we never use total anywhere, do we? Yeah, so I'm just going to change this to limit. And then we will change this to... Just make sure you get the same result. Yeah. And then we'll take this, and this will be our part 2. And we should be good to go. Where did I put part 2? And we will do it 74 times because we're off by 1. It bothers me slightly, but I'm okay with it for now. I'll change that in a minute. Oh. That's impressive. Okay. Yes, I have 2 input files. I do that on purpose. Yeah, it's interesting it took that long with an empty set. I mean, this is going to be a lot more. Kind of curious. I realize I could just let it run, but I'm too curious for that. want to see how long it takes to get through each index to see how long this is going to take theoretically. While that's going, do I need to optimize this further? What can I do to make this better? Well, anytime we have a 0, we know that the outcome is pretty deterministic. So we could leverage that. Zeros are always ones are always 2024s. And so we know what that entire chain is from the very beginning to the end, maybe. But then we have to maybe catalog that. Hmm. Let me get rid of this. And it's not going to work. Right. So what's our next move here? Um, if they're evens, they're always split. Can we somehow calculate, like, without having to step down each particular step, right? Because we're still processing on the first index here, just to get down to the 75th layer. It's interesting that you pointed out that it would hit the wall around iteration 44. Um, I don't know what iteration I'm at, but I can tell you that this is moving impractically slow at this point. So I made a more optimized part 1 and still have a pretty terrible part 2. So we know that if there's any number that's even, so like 8434, that we can skip. Okay, that's fun. Um, so any number that's even, so like 8434 or 2024 is always, we could always look at the length and we can skip forward that number of steps. So rather than for any of these that split, calculating each of those steps, we can say, okay, I know that what the value is going to be, and to step forward that number of iterations, to split forward that number of iterations. So I don't have to actually step down and split this and then split this. I can go and say, okay, we've got 4 steps of 1 X number of levels down, which would be the length of it, which is 4 divided by 2 in this case. So we're skipping forward 2 steps. And I think that's an optimization we can add. Anything that is even will have to be multiplied. Maybe those iterations still have to take place. And we know that 0 becomes 1, which becomes 2024, which then gets split into 2024. So we could optimize that as well. Or not 2024, into 2024, which then again repeats on the 1. Okay. I guess really we could optimize this just in itself. So let's think about this for a second. So we know what our left and our right side is, but let's not do that. Let's break this into and we've got our input, which is S, and then our separator, which is that. And so we've got that. So now shouldn't pass in a string to next only. Convert to the string if you need to. I mean, okay. So what you're saying is we should process them as ints or just as bytes? Because I understand that. Yeah. So I want to try to see what I can do here. I don't know if I'm going down the right route or not. But we're going to grab. So for each of these, I know that if they're even, we're going to split them all the way down until they're single digit numbers. So I can go ahead and do that for any even number. I can go ahead and split it down to the even digit numbers. And I know that in order for it to do that, it's going to take half the number of steps. So if it's 4 numbers, it's going to take 2 steps to get them down to their individual components. So I can skip all of that and I could just say, okay, what is our we'll just call it that for now, which is length of S. And I know that we can do step plus skip. Maybe that's close. And then the next is going to be C. But I need to add skip to my total. And so I think what I want to do is yeah, I thought about okay. So if I take this approach then, and I can say that our total we'll do total plus equal skip plus And then that's not true yet. And then we return total here, I think is what we want to do. And so um what do you mean, Tim? I'm just out of curiosity. Like, what do you mean the problem is here isn't computing the next state? It's the way you're defining the current state. So this isn't going to work because if half of it is zeros, yeah. But I'm not necessarily storing state here though, am I? Like not with this solution. I'm moving on to the next possible state. I guess they are forking, so eventually we get down to some level of some, recursive function. Okay. 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 I guess this doesn't work for 6 because if it's not an even number, like divisible by, if it's, well, 2 is, well, it's, yes. So it would only work for like multiples of. Yeah. So if we stored like a 0 in a map, well, so 0 0 becomes 1 1, which becomes 2024 2024, which becomes 2024 2024. Yep. So this solution is not going to work. This attempt at optimization is not going to work here. Let me unbreakify what I just did here. It's an interesting idea. Yeah, no, exactly. So, but the question is like for each iteration, how far do we go until it's a recursive like loop so that we can kind of skip path, right? So if we let's play with this idea a little bit here. So 0 becomes 1, which becomes 2024, which becomes 2024, which becomes 2 0 2 4, which then becomes what? So we know what this state is. But this is only looking at 0, right? So, I mean, maybe we know a shortcut for 0, but is that the answer that there is a shortcut? So 2 times 2024 is 4048. So this is 4048. And then this is 1, and this is 4048, and this is, which is 8096. Well, what do you mean by each possible input to step? So, like, it also depends on, like, what eventually is the end state, right? So, because it depends on how far down you get, right? So, maybe I'm just not seeing it. So you memorize the stone and the current step. So we know when we, what I'm interested in is if this eventually comes back, right? So we know all these zeros are going to put us into a set where we can get back to 2024. It's 1, 2, 3, 4 steps. If I want to go down this path. Oh, that's interesting. Interesting. That is interesting indeed. So, but I'm not, well, okay, let's think about that for a second. So I'm not actually storing the number, but I am passing the string down each reference to like each iteration of the function, which is going to take up space and memory for that. And so 75 blinks in 90 milliseconds. Interesting. I like this idea, Tim. This is a great idea. I'm just trying to think in my mind here how I would. Is this does this mean that my initial uh part one was actually not as terrible of an idea as I initially thought? No, it's still pretty terrible because I was expanding this slice every time and I was looping through it every time. Um, so then how do I make this optimized, right? How do I not pass the character down each time? um, to the next, unless the answer is that I keep them as a set of references as I see each one, because hmm, hmm, the list's not that long after 25 blinks. Yeah. I mean, I did attempt the brute force initially, but then I switched to this method, which was just like it's a recursive function. And the benefit here is that we're calculating each stone as we calculate them. So it was much faster than reprocessing the string, which is a really bad idea. I suppose this is still not like super elegant, but I hear what you're saying here. I think I'm on to where you're headed. I'm just trying to think how I'm going to articulate that. Um, I guess the answer is I'm going to follow one of these paths all the way down 75 steps. And what you're saying is that if I have if I already have a stone and a step, yeah. Well, we have recursion here, right? We just don't have the memorization. Oh, you're saying you did pedantic. Sorry, mispronunciation. And I'm sure the memorization helped, right? So, okay. Um, yeah. Multiple times repeat the result each time, but don't have to. Yeah. Okay. So I don't have to. I'm learning here, right? So we can. I understand if I have a stone, a value of a stone, I can calculate some level of depth, right? Um, I know that if I have like a zero, for instance, I can know up to the 10th step of a zero. Um, just as an example, or I can know that with a zero from 10 steps, if I have 10 steps, I can calculate up to that point. But I have to have zero from the top, which I guess I do here if I was to think about that, if I was looking at it from a zero perspective. But then it's calculating all of those numbers to what degree of depth? That's the question. To what degree of depth? So I'm not piecing that last piece together for some reason. And I understand where the optimization is headed here. I don't I don't know that I get that last part. So stone step pair int. So you're saying that I would like record zero step zero with the value that it gets, and once that calculates once, that would be stored, and then each time we iterate on that particular pair. Okay. So we'll play with it here. So, okay, maybe we'll pass it in. Sure. Let's pass it in. Let's pass it in. We'll call it cash. Why not? I think I understand where we're headed here. So just call it cash. And then at the beginning, we'll create this. And then on part 2 as well. All right, so we get a map that we're passing in. It's going to be by reference. So that should be fine. And then what we're saying is for each value, we're going to look at what that step is. So perhaps interesting. All right, so then what we can do here is I'm trying to think of how I want to articulate this, because really, like, this is going to be okay. I guess if we have our and if we put in here something like %d colon %d, this is what you're saying here is that we're going to put our stone, which is actually that, in our step pair, and it's going to be equal to I guess we could say okay, return that. Return V or something like that, right? So we don't have to iterate down the rest of the steps. Okay. So something to like that degree is what we're talking about here. Of course, I'm not setting the map anywhere at this point. So then it's kind of ugly, but we'll go with this for right now. Something like that. And then something like that. Got it. Cool. All right. Well, so I think what this meant is that as we were processing and we were splitting, kind of seeing it now and seeing it work, as we were splitting up those values, we were optimizing by saying we don't have to recalculate these. So once we calculate, like say the leftmost path, we had other paths that could be finished more quickly. And then it just became finishing out those paths. Thanks, Caleb. I appreciate your help. I appreciate everybody kind of hanging out and just walking through this process with me. It's feels good to actually get it finished here and do it in pretty optimal time actually. Not completion of the thing, but the fact that it ran in less than a second uh, was pretty exciting to see. All right, well, appreciate everybody hanging out, and if you guys have any questions about what I do, or maybe you don't, let's see. The other way is to use a map of frequencies and numbers, which is like the Y2021 fish problem. Map of frequencies. Yeah, I'd have to go back and take a look at that one. I started like in 2022 and really just kind of messing around with it. I think this year I'm kind of taking it a little bit more seriously. I did some videos last year, but just kind of playing around with it. So, but I do appreciate everybody hanging out and interested to see where this goes tomorrow night. So, but yeah, I mean, if you guys want to hang out or if you want to see more things like this, like feel free to like and subscribe. If you want to see me struggle in the future, by all means, go right ahead and we can struggle together, I guess. Or maybe you don't struggle and I just struggle and you laugh and eat popcorn. Why cry? I'm just kidding. But that's all I have for tonight. So I'll let you guys go. I'll see you all next time. You have a good night. Bye. I mean, yeah, Caleb, if you want to, sorry, I was going to name my stream, but didn't. Yeah, if you want to share it, I mean, by all means, I'd be interested. I might revisit at some point. Um, but yeah, feel free to PM me or send a message here or comment in this particular live stream and we'll take a look at it. Do you have it now? I can just open up the Git repository. We can look at it right now on stream. This is when things get awkward, right? You try to end the stream and then decide not to last second because you see something interesting. Yeah. So here, if you send it my way, yeah, if you send it my way, I'd love to take a look at it, kind of see it, and oh, let me take a look here and see what you've got going here, Caleb. It might have been filtered out. Let me see. Let me change to all messages. I'm just looking at the YouTube chat right now to see if I can see it in here. Yeah, I don't see it. Let's see here. See if I can go to. Yeah, no. I don't see a way. I don't see anything that's like hidden or filtered out though. So maybe I just missed it or I can't find it. Uh, let's see if we can do this. Yeah, I don't see it. Oh no, it's okay, Caleb. Yeah, it's fine. We could revisit it at a different time. It's all good. I'll see if I can find it in the video chat somewhere. I mean, do you have like a GitLab channel you can like, or a GitHub like account I can go look at maybe? Or so you're talking about if we were to look at it here, we go to 2020. Oh, I guess I did do 2021. What day on 2021? Let's see here. 2021. Sorry, now I have to go back in the chat and find it. Day 6. Found it. So I did day 6 then. Lanternfish? Is that the one we're talking about? Do I not have it here? Oh, you know what? Hold on. My original, I don't think I had them. Oof. Maybe I didn't include it. I mean, whatever works for you. If you had a link or something I can look at, or you can point me to it, I can go look it up. I'm interested. Like, let's take a look at it now. Well, let's take a look at the problem. After one day, its internal time would become 2, become 1, 0, 2. I wonder if I have. Yeah, I don't know if I actually have when I solve those problems then, which is kind of a bummer. Oh, I know where I know which MacBook they're on too. Okay. Well, we can look through this. So, initial state after some days, things kind of expand out. It's very similar to what we're dealing with here. They got some rules. After one day, its internal time would be 2. After another day, the internal time would become 1, 6, 8, 7, 6, not 7. And then part 2, similarly. Oh man, I wish I had access to that. I think I deleted it all. How many lanternfish would there be after 256 days? Gotcha. Interesting. I wish I had what I had. Okay. Yeah, let's try it. Let's try it. That's fine. We'll find it. I understand. Let's try to do this. Yeah, here we go. this is so is it in the 2020, like which directory here? This is AOC 2024. You put it in day 11, I'm going to guess. And then the, oh, hey, not that it really matters here, Caleb, but someone mentioned this to me a couple of streams ago. Putting, putting the input text in the Git repo is kind of frowned upon. The AOC guys asked for us not to do that. Nice. Okay. Read input, it's fine. Blank impl, string map int. Stones turns it into that. Range map keys. Count. Okay. Oh, I see. I see what's going on here. So you end up with a map and you mark the initial set of those stones, and then each iteration you take that map, just using that map, and you go through the logic, and anytime you see a stone that already exists, you increment the counter. Otherwise, you add the stone. Where's the... stones left, stones right. Gotcha. Okay, that's awesome, man. No, this is great. It's great stuff. And then we just sum through the values based on whatever count is in there for the given key. So we could, I mean, we can change my answer, but I mean, we got it here, so I'm not going to walk through it, but I see how this is a better solution. But, well, awesome. Well, it's great hanging out, guys. We'll do it again tomorrow. I'll see you all at 12 a.m. tomorrow morning or night, whatever it is. But y'all have a great night.